Howdy, calculus folks. What we're going to do today is we're now going to start getting into the third main topic, or the third main subject, whatever you want to call it, inside of calculus. Calculus is basically split up, well, introductory calculus is basically split up into three subjects: limits, derivatives, and then this third one is often called antiderivatives or integration. This word, antiderivative and integration, they're not exactly synonyms, but they are basic. You can think of them as synonyms. An antiderivative is a noun. Integration, it's a noun too. It's the subject of antiderivatives. And so basically what we're doing here is we are antiderivative, anti meaning opposite or against, derivative. So, or anti often refers to something that is backwards from something else. That's exactly what we're doing here. The subject of integration is concerned with backwards derivatives. And let me show you an example. Let's say that we have the function y equals x to the third power. Well, you have learned, if you learned your derivatives, that the derivative y prime is equal to 3x squared. Okay? And so basically what I'm about to teach you in antiderivatives or integration, and if I use integration or the word antiderivative, I basically mean the same thing. Okay, so there are some math people out there that would split hairs over the words, and that's fine. I'm glad that there is a technical difference in certain people's minds about that. But for you at an introductory calculus level, for now, it's okay. These two words basically mean the same thing. All right, so look, if I'm going to do the antiderivative of 3x squared, the antiderivative of 3x squared is going to be x to the third power, because an antiderivative is doing a derivative backwards. So you go from a function to its derivative back to the original function. That's what an antiderivative is. Okay? So in order to teach you that, now there is a technical, I didn't include something very important with this antiderivative, but we're going to get to that in just a couple minutes, so just be patient. Okay? First, I want to show you the symbol that we're going to use when doing integration. Okay? The symbol that we use to integrate, the way that you know whether you are going to be integrating something, is there's a special symbol that means integrate this, this expression. And it looks like this. It's sort of an elongated S. That is the integration symbol. So if you have ever seen that symbol, that means integrate. And when you see that symbol means integrate this expression. So if we were to say integrate the expression 3x squared, and then what you'll always see at the very end is you will see you'll see this little piece that says dx. Unless if the letter you're integrating is the letter t, then this would say dt. If the letter you're integrating is the letter u, then this would say du. And this piece is very, very important. It tells you the variable, the input variable that you're integrating with respect to. So what we would say is integrate 3x squared with respect to x. Okay? And basically this integral symbol and this dx, they're like parentheses. You know, if I were to say my name is Michael, but parenthesis, but my friends call me Mike. And then I would put a period. This would probably drive you crazy because you're thinking to yourself, hey, you forgot to close the parenthesis. Well, it's the same thing with integration. If we do this, if we just say integrate 3x squared equals, or the indefinite integral of 3x squared equals, this is going to drive math people crazy because you didn't close the parenthesis. You opened the parenthesis, but you didn't close the parenthesis. You have to close the parenthesis just like I have to close the parenthesis here. So it's very important that you put on this dx. Okay? All right, one more technical detail. Okay, so now let's get on to what it is that I'm going to teach you today. Now that you understand this dx, you understand the integration symbol, you understand the basic idea of what we're doing with integration, what we're going to do today is called an an indefinite integral. Indefinite integral. Now, I can't really explain fully what indefinite integral means until you learn what a definite integral is. I can give you a beginning understanding, but in the next lesson, you're going to learn what a definite integral is. Then, what you're learning here is going to make a lot more sense than it does right now, okay? Or it will even by the end of the video. But the idea of an indefinite integral goes like this. Let's say, let's stick with the same example. Y is equal to x to the third power. But what if instead of it being x to the third power, what if it's x to the third power plus 7? Well, what's the derivative of x to the third power plus 7? Well, the derivative, y prime, is 3x squared. Why don't we have anything over here? Why didn't we do anything with the 7? Well, hopefully by now you have already learned that when we do the derivative of a constant, it goes away because the rate of change of a constant is 0. And therefore, the derivative of 7 is 0. And this would be 3x squared plus 0, but we don't write the plus 0. But there's a problem, because if we had a completely different function, let's say that we had w is equal to x to the third power plus 9, wouldn't w prime, wouldn't the derivative of this also be 3x squared? We have two different functions that each have the same rate of change. They have the same derivative. And this is going to become problematic, because when we do the indefinite integral of 3x squared here and do the indefinite integral of 3x squared here, there is nothing in the integral, there's nothing here that's going to communicate to you that there's supposed to be a 7 with this after you get its integral. And there's nothing here to indicate that there should be a plus 9 on the integral. So we know that the antiderivative of 3x squared, because it came from x to the third power, that the antiderivative would be x to the third power. And the same thing over here. This derivative came from x cubed, and so its antiderivative should be x to the third power. But the problem is, this originally came from x cubed plus 7, and this originally came from x cubed plus 9. But there's no way at all, at least not yet, there's no way of knowing that this is supposed to be x cubed plus 7 and that this is supposed to be x cubed plus 9. So what we do, this is very, very important, just like closing off the integral, when you do an indefinite integral, what we do is we put the term plus c on the integral to indicate that there was, is, could be, there was a constant there, and we don't know what that constant is. So c, the letter c is representing a constant. Now, it depends on who your calculus teacher is, who your calculus professor is, whether you're taking AP Calculus or Calculus 1 in college. And it depends on where your college is, what country it's in, what state it's in, which professor you have. Different professors use different letters, and different textbooks use different letters. Sometimes, instead of plus C, they will use plus A. They will use plus A. And because the letter K is often used as a constant, I'm sure somebody out there would use plus K, x cubed. And it doesn't matter what letter you use. I mean, as long as you don't use I or E, and certainly not X. But basically, you have to put on here a letter that represents a constant. In my class, that letter will be C. So, the antiderivative of 3x squared with respect to x is x cubed plus c. And this is the exact same problem. So the answer is the exact same, x cubed plus c. So now that we've got some introductory stuff, you understand that when you do any indefinite integral, in fact, this plus c is what makes it indefinite. That's why it's called, one of the reasons why it's called an indefinite integral is because the antiderivative itself is not definite. It's not actually a function. It is a family of functions. There are an infinite number of possibilities here. This could be x cubed plus 1, x cubed plus 2, x cubed plus 3. It could be x cubed plus 7.92. It could be x cubed minus 5. It could be x cubed minus 11. Infinitely possible here with this plus c. This is an indefinite integral. So now that you have all of this beginning information, now I can actually show you how to do an indefinite integral. Well, the most basic way of understanding an indefinite integral is if you know that what you're looking at is the derivative of a particular function, then just do that. You may already know that 2x is the derivative of x squared, and therefore the antiderivative of 2x with respect to x is x squared plus c. Okay? So if you already know that what you're looking at here is the derivative of another function, then that other function is the answer to the antiderivative, and then you just have to put on a plus c. But what I'm going to show you now is what I call the power rule of antiderivatives. Okay, the power rule. Just like we had a power rule of derivatives. All right, so this is the power rule. Okay? Well, the power rule when we did derivatives went like this. If we had y is equal to 5x to the third power, and we wanted the derivative, y prime, we would first multiply, so step one would be multiply the exponent by the coefficient. That's step one. The coefficient is 5, the exponent is 3. 3 times 5 is 15. Right? That's the first step. Second step for the power rule is reduce the exponent or power, reduce the power by 1. Reduce the power by 1. This is x cubed, reduce it by 1, now it's x squared. So the derivative of 5x to the third power is 15x squared. We're done. There we go. So the power rule for an antiderivative is basically going to be these two steps backwards. And when I say backwards, I don't just mean we're going to do the steps backwards, but we're actually going to, in fact, let me change this, reduce the power, subtract, let's do this, subtract 1 from the power. But we're actually going to also reverse the operations. So the power rule for an indefinite integral, if it's a polynomial function, is going to go like this. Instead of doing step 1, we're going to do step 2 first. And instead of doing subtract, we're going to add. Instead of subtracting from, we're going to add 2. So add 1 to the power. So the first step, add 1. Oops, that's an A, not an add. You add. Add 1 to the power. Okay, so if we're doing the antiderivative of 15x squared dx, the first thing we're going to do is we're going to add 1 to the power. Well, what is the power here? This is x to the second power. So the answer is going to be x to the third power. X to the third power. And then step 2 is going to be, instead of multiplying, we're going to divide. Divide the exponent, well, actually it's the other way around. That's right, we're going to do it the opposite. We're going to divide the coefficient by the exponent. Okay? So we have 15, and we're going to divide that by the new exponent. We're going to do 15 divided by 3. So 15 divided by 3 is equal to 5, right? So this is now 5x to the third power. So divide the coefficient by the new exponent, not the old exponent. We're not going to divide 15 by 2. We're going to divide 15 by 3, the new exponent. So 15 divided by 3 is 5. And then lastly, step 3, we are going to plus c. We're going to put a plus c on it. And so 5x cubed plus c. This is our indefinite integral of 15x squared. Okay? Now I do want to modify this step 2. I want to modify this step 2 for a second. Here's what I need you to understand. Let's say that we had an algebraic equation that was 4x plus 3 is equal to 23. And I said, solve for x. Here's what you would do. You say, well, I'm going to subtract 3 first from both sides. Good. Now we have 4x is equal to 20. And then you're going to say, well, I'm going to divide by 4. Stop. Hang on a second. Yes, you're going to divide by 4. This is what you've always learned how to do. We're going to divide by 4 here. We're going to divide by 4 here, cancel, and we're going to get x equals 5. But hang on a second here. Dividing by a number is actually multiplication of sorts. Let me show you what I mean. Instead of dividing by 4, divide by 4 means the same thing as multiply by the reciprocal of 4. The reciprocal of 4. Well, what's the reciprocal of 4? The reciprocal of 4, the reciprocal of a number is its fraction flipped over. 4 is actually equal to 4 over 1. So the reciprocal of 4 is 1 over 4. And what I'm telling you is that dividing by 4 is the same thing as multiplying by 1/4. It's the same thing. And so here, instead of dividing by 4, we're going to multiply by 1/4 on both sides. Multiply by 1/4. What is 1/4 of 4? It's 1, so it cancels. And all we have left is x. What's 1/4 of 20? Well, that's 5. So dividing by 4 is the same thing as multiplying by 1/4. Now, the reason I'm changing this is because there are certain situations in calculus where you integrate, where dividing becomes confusing. And I'm going to do an example in just a second. Okay? In fact, let me go ahead and do an example right now. What if I asked you to do the, and we'll erase this, what if I asked you to do the indefinite integral of 3/7 x to the 4th power dx, right? And so here's what you would do. Oh, I know how to do this one, Mr. Ryan. I know the power rule of antiderivatives. I know that I need to add 1 to the power. And so we're going to add 1 to the power, and it's going to become x to the 5th power. And then you're going to divide by the coefficient. Well, the coefficient is 3/7. 3/7. And you're going to divide it by the new exponent, and the new exponent is 5. So now what you come up with is 3/7 divided by 5. So you have a fraction inside of a fraction. Are you happy? Does this, if you saw this on a test, would this make you happy or would this make you sad? Most people, you may say, I don't care. Good. Well, you're good with fractions. Most people, most students that I know would look at this and they would say, that makes me very nervous. That makes me anxious. I don't like seeing fractions in fractions. Okay, good. Well, then let me show you what you should be doing. Instead of dividing by 5, multiply by 1/5. Here's what I mean. Add 1 to the power, x to the 5th, bring over the coefficient, and now multiply by the reciprocal of the power. The reciprocal of 5 is 1/5. So we're going to multiply by 1/5. This is much easier. I can do 1/5 times 3/7. That's 3 over 35. That makes me much happier because I don't have a fraction inside of a fraction. Okay? So we're going to change the power rule from divide the coefficient by the new exponent to multiply the coefficient by the reciprocal of the new power. Okay? And so now, if we want the antiderivative of 3/7 x to the 4th, we're going to increase our power by 1. So this is going to become x to the 5th. Then we're going to take 1/5 and multiply it by 3/7. And 3/7 times 1/5 is 3/35. And so we're just going to put a 3/35 in front of the x to the 5th. And then we're going to put on a plus c. And there is our antiderivative. Okay? And if you want to check it, if you're thinking, oh my goodness, how do I find, how do I know that that's the right answer? Well, just find the derivative of it. Do the derivative, and if the derivative of this is equal to what's inside of here, this is called the integrand. The integrand. You should write that down in your notes. It's called the integrand. The expression that is inside of the integral symbol. It's called the integrand. So if you do the derivative of your answer and you get the integrand, then you did it correctly and you're good to go. Okay? Let's do a few examples with the power rule. I think you're going to become very comfortable with the power rule after we do a bunch of examples. All right, and we'll start off with the easy ones instead of doing those hard. That one we just did was a little challenging, right? All right, so let's see here. Let's say that we want to integrate 10x to the 4th power dx. Okay, so we're going to power up. We're going to increase the power by 1. So this is going to become x to the 5th power. And then we're going to multiply 10 by 1/5. Well, what's 1/5 of 10? 1/5 of 10 is 2. 1/5 times 10. And that basically comes out to be 10 divided by 5. And that is 2. Okay, 1/5 of 10 is 2. And so then we put on a plus c, and there is our antiderivative. And so the antiderivative of 10x to the 4th is 2x to the 5th. And I can prove it. What's the derivative of 2x to the 5th? 5 times 2 is 10. X, reduce the power by 1, 10x to the 4th, and that is the same as my integrand. So I must have done it correctly. Let's do another one. How about the antiderivative of 50x to the 9th power? 50x to the 9th power. Do you want to pause the video and try this on your own? Okay, so step 1 is we're going to power up. So it's going to become x to the 10th power. Then we're going to multiply by 1/10. 1/10 of 50 is 5. And if you want to, in your mind, if you want to just divide by 10, 50 divided by 10 is 5, that's fine. It's just when you get to the ones where you're dealing with fractions, you want to make sure that you're multiplying by the reciprocal. Okay? And so it's 5x to the 10th, and then we got to put a plus c on it, and that is our antiderivative. Let's just do a couple more. How about the antiderivative of x to the 3rd power dx? Antiderivative of x to the 3rd, we're going to power up, increase the power by 1. So 3 is going to become a 4, so it's x to the 4th. And then the reciprocal of 4 is 1/4. So we're going to multiply 1/4 times what's in front. And there's nothing up there except a 1. So it's 1/4 x to the 4th. Then we put a plus c on there. And there we go, 1/4 x to the 4th plus c. Let's do just one more. How about the antiderivative of 3x to the 5th minus 7x to the 4th plus x to the 3rd dx? You might say, whoa, Mr. Ryan there, you put too many of them in there. All right, here's what you do. With addition and subtraction, you just do the individual, do the antiderivative of this, then the antiderivative of this, then the antiderivative of this, and then put the signs in, okay? So the antiderivative of this whole thing is, just do one at a time. 3x to the 5th, power up becomes a 6, then multiply by 1/6. So that's 3 over 6 x to the 6th. minus, power up this 4, this is x to the 5th, so minus, it'll be x to the 5th, and then 7 divided by 5 is 7/5, so 7/5 x to the 5th, and then plus, power this up to a 4, so that's x to the 4th, and then 1/4 times 1 is 1/4. Now we can clean this up. See this 3/6? That's a 1/2. So really, this is 1/2 x to the 6th minus 7/5 x to the 5th plus 1/4 x to the 4th. And then, of course, we have to put on the plus c. Whenever we finally get our answer, we just put on a plus c and we're done. This is the antiderivative of this. Okay? All right. We're going to move on now to some of the rules for antiderivatives. And I think you're really going to start to get the hang of it. But this first rule, this power rule, is sort of the basic starting introductory rule for antiderivatives. And I hope you start to get the hang of this.